Hello and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It is Saturday, February 21st, 2026, and you are locked in for Season 5, Episode 45. We have got a packed show for you today.
We really do. We are just 2 weeks away from what could be one of the most significant launches in the history of human spaceflight, and the crew is now officially in quarantine. Humanity is going back to the moon, people.
Beyond the moon, actually, for the first time since 1972. We'll have the full Artemis 2 update in just a moment. Plus, scientists may be challenging the very foundations of dark matter theory. There's a solar storm brewing that could light up the skies as early as tomorrow night.
Mars is holding water a lot closer to home than we thought. Great news if you're planning to move there. And astronomers have confirmed that supermassive black holes are not content with just destroying their own galaxies. Apparently, they've been going after the neighbors too.
Serial killers of the cosmos. We'll explain. And we'll wrap up with a SpaceX story that came very close, their words, not ours, to being a very bad day.
Let's get into it.
All right, let's start with the big one. As of yesterday evening, Friday, February 20th, 2026, the 4 astronauts of NASA's Artemis 2 mission have officially entered quarantine in Houston, Texas.
And if you know anything about space mission protocols, entering quarantine is one of the clearest signals you can get that a launch is genuinely imminent. NASA is targeting no earlier than Friday, March 6th, and that clock is now ticking.
So let's set the scene for anyone who needs a quick refresher. Artemis 2 is the second mission of NASA's Artemis program, and it will be the first crewed mission to travel beyond low Earth orbit since Apollo 17 back in December 1972. We're talking more than 50 years.
53 years, to be precise. And the crew that will make this historic journey consists of 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, and mission specialist Christina Koch from NASA, and mission specialist Jeremy Hansen from the Canadian Space Agency.
They entered quarantine at approximately 5 p.m. local time on Friday evening in Houston. The quarantine period is typically about 14 days, during which the crew limits their exposure to other people to make sure they stay in good health before launch. They'll fly down to Kennedy Space Center in Florida about 5 days before launch day.
And the reason NASA is feeling confident enough to put them into quarantine now is the success of the second wet dress rehearsal, which took place on Thursday, February 19th. Now, Avery, for the uninitiated, what exactly is a wet dress rehearsal?
Great question. A wet dress rehearsal is essentially a full dress rehearsal of launch day, except you don't actually light the engines at the end. The teams load the rocket with its full complement of cryogenic propellants. In the case of the Space Launch System, that's more than 700,000 gallons of super cold liquid hydrogen and liquid oxygen, and then run through the entire launch countdown sequence right down to the final seconds.
And the reason they needed a second rehearsal was that the first attempt on February 3rd had to be called off when a hydrogen leak was detected. Engineers replaced seals and a filter in the ground support equipment, and on Thursday night they ran the whole thing again. And this time, hydrogen concentrations stayed within safe limits throughout.
They actually ran through the terminal countdown, the final 10 minutes, twice. The test concluded at 10:16 Eastern Time, stopping at T-minus 29 seconds as planned. Now, there was a minor communications glitch in the Launch Control Center that caused a brief delay early in the test, and a booster avionics voltage anomaly that paused the terminal countdown for a short time. But both were resolved, and NASA declared the rehearsal a success.
So, what happens next? Data from the rehearsal is being reviewed. There's final work to complete at the launch pad, including retesting the flight termination system. And then a flight readiness review has to take place before a formal launch date can be set. But all signs are pointing to March 6th.
Launch windows for lunar missions are quite tight, by the way. They're determined by the alignment of the Earth and Moon, so you can't just pick any day. The available windows are March 6th through 9th, with an additional opportunity on March 11th.
If Artemis 2 launches successfully, it will send 4 human beings on a 10-day journey around the moon using a free return trajectory. meaning that even if the Orion spacecraft's propulsion system doesn't perform as planned, the crew will still safely return to Earth. They splash down in the Pacific Ocean.
It will not orbit the moon or land. That's Artemis 3's job, but it will take people further from Earth than any humans have been in over half a century, and that is extraordinary.
It really is. We will be following every step of this one very closely. March 6th, people, mark your calendars.
Now, from the very near future to the very deep past, cosmologists have spent decades trying to understand dark matter, the mysterious invisible substance that appears to make up about 27% of the universe and which we've never directly detected. And a new paper just published in Physical Review D is making a bold claim.
Bold claim is something of an understatement. The authors say their findings represent, and I want to make sure I get this right, the first step towards the end of dark matter theory.
That's a sentence that would cause an awkward silence at a cosmology conference.
I imagine so. So, what are they actually saying? The paper reports the discovery of a significant number of new baryonic dark matter signals. Now, baryonic matter is essentially ordinary matter, the stuff made of protons, neutrons, and electrons, the kind of matter that makes up you, me, planets, stars, everything we can see and touch.
Right, and the conventional model of dark matter says that the mysterious missing mass in the universe is made of something else entirely. Non-baryonic matter, exotic particles that don't interact with light, which is why we can't see it directly. We infer its existence from its gravitational effects on galaxies.
So, if these researchers are finding that a lot of what we've been attributing to exotic dark matter can actually be explained by ordinary baryonic matter that we just hadn't accounted for properly, that's a very significant challenge to the standard model.
Now, to be clear, the paper doesn't claim dark matter doesn't exist. It claims this is the beginning of the end of dark matter theory as it currently stands. Whether that means a revision or a revolution, we'll have to wait and see.
This is the kind of paper that will generate a lot of discussion in the community over the coming months. We'll be keeping a close eye on the responses and follow-up research. Fascinating stuff.
Now, a very timely heads up for all you sky watchers out there. And by timely, I mean you may want to check your local forecast for tomorrow night.
That's right. Space weather forecasters are currently tracking a large coronal hole on the sun that has rotated into what's called a geo-effective position, meaning it is now pointing directly at Earth.
So, a coronal hole is a region on the sun where the magnetic field lines open outward rather than looping back in. That configuration allows fast-moving solar wind to escape directly into space. And when that fast solar wind is aimed at us, it can interact with Earth's magnetic field and trigger geomagnetic storms.
And geomagnetic storms are what drive auroras, the northern and southern lights. The effects from this particular coronal hole are currently expected to arrive around February 22nd. That's tomorrow. Forecasters are predicting the solar-wind interaction could disturb Earth's magnetic field and boost aurora activity.
Conditions today are relatively quiet. The coronal hole-driven effects from a previous solar wind stream are fading, but tomorrow night could be a different story. If you're in higher latitude regions, northern parts of the US, Canada, the UK, Scandinavia, southern New Zealand, and Australia, it's worth watching the skies after dark.
We should also mention that in the past few days, Earth sky has been tracking some very dramatic solar features, twin prominences visible on opposite sides of the sun simultaneously, glowing in data from the GOES 19 satellite. Solar activity is really putting on a show right now. We're deep in solar cycle 25, and the sun is reminding us who's boss.
Keep an eye on spaceweather.com and EarthSky for live updates as that solar wind approaches. And fingers crossed for clear skies.
All right, let's head to the red planet. If there's one resource that will make or break any long-term human presence on Mars, it's water. You need it for drinking, for growing food, for producing rocket fuel. And new research is suggesting that accessible water ice on Mars may be closer to the equator than scientists previously believed.
This matters enormously from an exploration standpoint. When we talk about water ice on Mars, we typically think of the poles. There are substantial ice caps at both Martian poles, and they're well documented. But the poles are extremely difficult to reach. They're incredibly cold, and they fall under strict planetary protection protocols because of the possibility of contaminating any potential microbial life.
So, the ideal scenario for human explorers and for rovers doing science has always been to find water ice at lower latitudes, closer to the equator, where temperatures are more manageable and landing is easier. And this new research from a paper published in Acta Astronautica suggests that may be more achievable than we thought.
The researchers propose new methods for dealing with one of the key challenges of equatorial water ice extraction: the jagged, clingy nature of Martian regolith, or lunar dust. Martian dust gets into everything, and they describe flexible electrodynamic dust shields that could help manage the dust problem and make water extraction at equatorial sites more viable.
So, the picture is increasingly optimistic for Mars exploration. If future missions can confirm accessible ice deposits at mid-latitudes and develop the technology to extract and process that water efficiently, a long-term human presence on Mars becomes significantly more realistic.
One step at a time, but each of these steps matters. Really encouraging research.
Now, I mentioned in the intro that supermassive black holes have been going after the neighbors. Let me explain what I mean by that, because the new research here is genuinely striking.
We've known for some time that active supermassive black holes, the kind found at the centers of galaxies that are actively feeding on material, can have a profound effect on their host galaxy. Specifically, they can heat and disperse gas, shutting down the conditions needed for new stars to form. Effectively, they can kill their own galaxy.
But astronomers have now found evidence that the most luminous of these, called quasars, don't stop there. New research using data from the James Webb Telescope shows that the powerful radiation and outflows of quasars can suppress star formation in neighboring galaxies as well. Galaxies that aren't even directly hosting the black hole.
They're basically firing across the cosmic neighborhood. The energy output of an active quasar is so immense that its effects can extend beyond its own galaxy and reach into surrounding systems, cutting off the gas supply those nearby galaxies need to form new stars.
Researchers are now calling them supermassive serial killers. And honestly, given what the data shows, that label feels pretty accurate. What's particularly significant is the implication for our understanding of galaxy evolution. If black holes can shape not just their host galaxies, but entire cosmic neighborhoods, that's a much bigger role than we previously appreciated.
The James Webb Space Telescope continues to rewrite the textbooks. This research adds another compelling chapter to the story of how these extraordinary objects have helped sculpt the large-scale structure of the universe we see today.
Terrifying and magnificent in equal measure, which is kind of the theme of black hole research generally.
And finally, let's end on a story that's part triumph, part nail-biter. On Thursday, February 19th, SpaceX launched 29 Starlink satellites from Cape Canaveral and successfully landed the Falcon 9 first-stage booster not at their usual landing zones in Florida or their drone ships in the Atlantic or Pacific, but in the Bahamas.
Now, this is only the second time ever that SpaceX has landed a Falcon 9 booster in the Bahamas. The first time was not very long ago, so this is still very much a novelty. And what made this one particularly dramatic was the quote that came out of SpaceX after the landing.
Yes, someone at SpaceX said, and I quote, "We almost did have a really terrible day."
Which is not the kind of post-launch statement that fills you with warmth and reassurance. SpaceX haven't elaborated extensively on what almost went wrong, but the fact that the booster landed safely is obviously the key outcome here.
The Bahamas landing site gives SpaceX more flexibility for certain orbital trajectories, particularly for Starlink missions launching from Cape Canaveral, where the geometry of the orbit makes a Bahamas landing more efficient than trying to bring the booster all the way back to Florida.
SpaceX have now launched and landed hundreds of Falcon 9 boosters. The reusability program has fundamentally transformed the economics of spaceflight. But moments like this are a reminder that rocket recovery, even after hundreds of successful attempts, still demands total precision every single time.
Every landing is a controlled miracle when you think about it. Very glad this one worked out. Congratulations to the SpaceX team.
And that is your Astronomy Daily for Saturday, February 21st, 2026. What a lineup! Artemis 2 on the launch pad with the crew in quarantine, dark matter theory under pressure, solar storms heading our way, water on Mars getting more accessible, black holes on a neighborhood killing spree, and a SpaceX rocket making only its second ever Bahamas landing. Not a bad day's news from the cosmos.
If you enjoyed today's episode, please subscribe wherever you get your podcasts. Leave us a review. It really does help the show grow. And share us with a fellow space enthusiast. You can find all our show notes, links, and more over at astronomydaily.io. And follow us on social media at AstroDailyPod.
We'll be back Monday with more of the universe's finest headlines. Until then, keep looking up.
And stay curious, everyone. Take care.
Astronomy.